Welcome to Ultrasound Physics, Chapter 13, Real-Time Imaging. There are 52 questions, including flashcards, tables and multiple choice. You can jump to the multiple choice questions directly by clicking on the chaptered minutes in the description. Ready? Let's start. The images were displayed one frame at a time in a process is called what? It is called static scanning. The ability to create numerous frames each second is called what? It is called frame rate. List two factors that determine the frame rate. They are, 1. Sound speed in the medium. And 2. The depth of imaging. What is the speed of sound in soft tissue? 1540 mm per second, or 1.54 km per second. What is the unit of the frame rate? Hertz, or images per second. The ability to precisely position moving structures from instant to instant, which pertains to accuracy and time is what? It is termed temporal resolution. Temporal resolution is determined by what? Temporal resolution is determined by frame rate. Displaying a high number of images per second, high frame rate, makes the temporal resolution worse or better? High frame rate improves temporal resolution. Few images, low frame rate, reduce the temporal resolution. What is the unit of the temporal resolution? Hertz, or per second. What is the relationship between frame rate and the time required to make a single image? They are inversely related, reciprocals. Please note that the formula is T frame multiplied by frame rate equals 1. What are the two sonographer-controlled settings of an ultrasound system to determine frame rate? Imaging depth and number of pulses per frame, in each picture. How does imaging depth affect temporal resolution? Imaging depth and frame rate are inversely related. Shallow imaging increases frame rate and improves temporal resolution. Comparison between shallow and deep imaging. Shallow imaging has a short go return time, while deep imaging has a long go return time. Shallow imaging has a shorter T frame, while deep imaging has a long shorter T frame. Shallow imaging has a higher frame rate. Deep imaging has a lower frame rate. Shallow imaging has a superior temporal resolution. Deep imaging has an inferior temporal resolution. Remember that shallow imaging has SSSH. Deep imaging has LLLI. How does the number of pulses in each image affect temporal resolution? Pulses per frame and frame rate are inversely related, therefore, it's inversely related to temporal resolution. Three factors determine the number of pulses per frame. Three factors that determine the number of pulses per frame are: 1. Number of focal points. 2. Sector size. 3. Line density. The multifocus requires 3 times the number of pulses for each image. Therefore, the frame rate is less than that of a single focus. Comparison of single focus and multifocus. Single focus has 1 pulse per scan line, while multifocus has many pulses per scan line. Single focus has a shorter T frame, while multifocus has a longer T frame. Single focus has a higher frame rate while multifocus has a lower frame rate. Single focus has a better temporal resolution, while multifocus has a diminished temporal resolution. Single focus has a poorer lateral resolution, while multifocus has an improved lateral resolution. What is the main advantage of multiple focal zones? With multifocus, each scan line has better lateral resolution because it is narrow over a wide range of depths. What is another name of sector size? Sector size is also known as field of view. What is the relationship of field of view and frame rate? They are inversely related. Narrower images result in higher frame rates. Wider images result in lower frame rates. Comparison of narrow sector and wide sector. The narrow sector has fewer pulses per frame. Wide sector has more pulses per frame. The narrow sector has a shorter T frame. Wide sector has a longer T frame. The narrow sector has a higher frame rate, while wide sector has a lower frame rate. The narrow sector has a superior temporal resolution, while wide sector has an inferior temporal resolution. As seen in these images, field of view and frame rate are inversely related. Narrower images result in higher frame rates. Wider images result in lower frame rates. Ultrasound systems can alter the spacing between the sound beams is called what? Line density. What is the relationship between line density and frame rate? Inversely related. Images with fewer lines result in a higher frame rate, left. Images with more lines result in lower frame rates, right. What is the main advantage of high line density? Although high line density has a negative effect on temporal resolution, the gaps between the lines are smaller. These smaller gaps improve the accuracy of each individual image, which is also known as improved spatial detail resolution. Comparison of low line density and high line density. Low line density has widely spaced lines. High line density has tightly packed lines. Low line density has fewer pulses per frame. High line density has more pulses per frame. Low line density has a shorter T frame, while high line density has longer T frame. Low line density has a higher frame rate, while high line density has a lower frame rate. Low line density has a high temporal resolution, while high line density has a low temporal resolution. Low line density has a poor spatial resolution, while high line density has an excellent spatial resolution. How are temporal resolution and image quality related? The factors that enhance one characteristic often compromise the other. Lateral resolution improves with multifocusing. Spatial resolution improves with higher line density. Comparison between better higher frame rate and worse lower frame rate. Better, higher frame rate has shallower imaging. Worse, lower frame rate has deeper imaging. Better, higher frame rate has a single focus. Worse, lower frame rate has multiple focal points, improves lateral resolution. Better, higher frame rate has a narrow sector. Worse, lower frame rate has a wide sector. Better, higher frame rate has a low line density. Worse, lower frame rate has a high line density, improves spatial resolution. Multiple choice questions section. Which of the following forms of resolution improve when the frame rate increases? A. Lateral. B. Longitudinal. C. Temporal. D. Spatial resolution. The answer is C. Temporal. Temporal resolution is directly related to frame rate. Higher frame rate improves temporal resolution. Which of the following is consistent with improved temporal resolution? A. Color Doppler. B. More gray shades. C. More details. D. Higher frame rate. The answer is D. Higher frame rate. Frame rate determines temporal resolution. Higher frame rates, lower T frame, result in improved temporal resolution. All of the following decrease temporal resolution except A. Lower frame rate. B. Deeper imaging. C. Multifocus. D. Narrower sector. The answer is D. Narrower sector. Unlike the other choices, narrow sectors actually improve temporal resolution. Narrow sector images are created with fewer pulses than wide sector images. A sonographer adjusts an ultrasound scan to double the depth of view from 5 cm to 10 cm. What happens to the frame rate? A. It is halved. B. It doubles. C. It increases from 5 to 10 Hz. D. It is unchanged. The answer is A. It is halved. Frame rate and imaging depth are inversely related. If nothing else is altered, the frame is halved when the imaging depth is doubled. A sonographer adjusts an ultrasound scan to double the depth of view from 5 cm to 10 cm. If the frame rate remains the same, which of the following also occurs? A. Increased line density. B. Wider sector. C. Multi-focus imaging turned on. D. Narrow sector. The answer is D. Narrow sector. This is the only choice that acts to make each image in less time. Since the imaging depth is increased, something else must have happened to counteract with increased time to create each image. Generally, creating an image with a narrower sector takes less time. A sonographer adjusts an ultrasound to change the sector size from 90 to 45 degrees. Nothing else changes. What happens to the frame rate? A. It is doubled. B. It remains unchanged. C. It is halved. D. It is tripled. The answer is A. It is doubled. The frame rate is doubled since fewer pulses are needed to make the image. Since this question states that nothing else changes, the line density remains the same, and therefore, the frame rate increases. A sonographer adjusts an ultrasound to change the sector size from 90 to 45 degrees. The frame rate was unchanged. What else must have happened? A. Temporal resolution was doubled. B. Sector size was doubled. C. Line density was doubled. D. Imaging depth was halved. The answer is C. Line density was doubled. Since the frame rate is unchanged, the number of pulses per frame was also unchanged. If the sector size is reduced, some other factor must increase the number of pulses per image. The only answer that increases the number of pulses per frame is choice C. Line density was doubled. A sonographer, using a phased array ultrasound system, turns off the multifocus feature. What is the most likely consequence of this action? A. Frame rate decreases. B. Temporal resolution degrades. C. Imaging depth increases. D. Temporal resolution improves. The answer is D. Temporal resolution improves. Changing from multifocus to single focus reduces the number of sound pulses required to make each image. As a result, the time required to make each frame is reduced, the frame rate is increased and temporal resolution improves. A sonographer increases the line density from 1 line per degree of the sector to 3 lines per degree of the sector. What is the most likely consequence of this action? A. Frame rate increases. B. Temporal resolution decreases. C. Imaging quality decreases. D. Temporal resolution increases. The answer is B. Temporal resolution decreases. Increasing line density from 1 to 3 lines per degree triples the number of pulses in each image. As a result, the time required to make each frame is lengthened, the frame rate is reduced, and the temporal resolution decreases. In this case, the frame rate is reduced to 1/3 of its original value. A sonographer reduces the sector angle from 90 to 30 degrees. At the same time, the ultrasound system automatically increases the line density from 1 line per degree to 2 lines per degree. No other changes are made. What will happen to the frame rate? A. Increases. B. Decreases. C. No change. The answer is A. Increases. The frame rate will increase. At first, each image comprises a total of 90 sound pulses, 1 pulse for each of the 90 degrees of sector size. In the second scenario, each image comprises 60 sound pulses, 2 pulses for each degree. Since the 30-degree sector image comprises fewer pulses, T-frame is reduced and the frame rate increases. A sonographer reduces the sector angle from 90 to 30 degrees. At the same time, the ultrasound system automatically increases the line density from 1 line per degree to 3 lines per degree. No other changes are made. What will happen to temporal resolution? A. Increases. B. Decreases. C. No changed. The answer is C. No change. At first, each frame comprises 90 sound pulses, 1 pulse per degree, 90 degrees. In the second scenario, 90 sound pulses are also needed to make each frame, 3 pulses per degree, 30 degrees. Since the number of pulses per frame is unchanged, the T-frame is unchanged, and thus, temporal resolution is unchanged. Which of the following is most important in determining the frame rate of a system? A. Speed of sound in the medium. B. Dynamic range of the receiver. C. transducer frequency. D. Transmitter output. The answer is A. Speed of sound in the medium. Of these choices, the speed of sound in a medium is the most important factor in determining frame rate. Which of the following is most important in determining the frame rate of a system? A. Depth of view. B. Dynamic range of the receiver. C. Transducer frequency. D. Transmitter output. The answer is A. Depth of view. What is the frame rate if each image of the ultrasound system is created in 0.02 seconds, 1/50th of a second? A. 20 Hz. B. 100 Hz. Circa 50 Hz. D. 15 Hz. The answer is C. 50 Hz. Frame rate and T-frame are reciprocals. In other words, the T-frame multiplied by the frame rate equals 1. If the time to make a frame is 1/50th of a second, then the frame rate is 50 per second or 50 Hz. What is the time needed to make a single image if the frame rate of an ultrasound is 20 Hz? A 1 second. B. 0.02 seconds. C. 0.05 seconds. D. 15 Hz. The answer is C. 0.05 seconds. Frame rate and T-frame are reciprocals. In other words, T-frame multiplied by the frame rate equals 1. If 20 frames are created each second, then T-frame is 120 or 0.05 seconds. True or false? The critical factor in determining frame rate, line density, and imaging depth is the transducer style. The answer is false. Time is the critical factor in determining frame rate, line density, and imaging. True or false? The number of lines per frame and the frame rate determines the frequency. The answer is false. The number of lines per frame and the frame rate determines the pulse repetition frequency, PRF. True or false? The number of lines per frame and the frame rate determines the pulse repetition frequency. True. True or false? If the imaging depth of a scan is 15 cm and there are 100 lines in the image, then the number of pulses making up the scan is 1,500. The answer is false. If the imaging depth of a scan is 15 cm and there are 100 lines in the image, then the number of pulses making up the scan is 100. True or false? If the imaging depth of a scan is 15 cm and there are 100 lines in the image, then the number of pulses making up the scan is 100. True. If the imaging depth of a scan is 15 cm and there are 100 lines in the image, then the number of pulses making up the scan is 100. True or false? If 100 scan lines make up an image and the frame rate is 30 per second, then the transducer's frequency is 3000 Hz. The answer is false. A transducer's frequency is independent of the characteristics of the image that it creates. True or false? If 100 scan lines make up an image and the frame rate is 30 per second, then the system's pulse repetition frequency is 3000 Hz. True. Pulse repetition frequency is the number of pulses created per second. In this example, it is lines per image multiplied by the frame rate. When the frame rate is 30 Hz, how long does it take to create a frame? A. 30 seconds. B. 3 seconds. C. 0.03 seconds. D. 1/30th of a seconds. E. 1/3 of a seconds. The answer is D. 1/30th of a seconds. Remember that frame rate and T-frame are reciprocals. Therefore, if the frame rate is 30 per second, the time to create each frame is 1/30th of a second. Under certain conditions, an ultrasound system creates each image in 0.01 seconds. What is the frame rate? A. 1 Hz. B. 10 seconds. Circa 100 Hz. D. 200 Hz. E. 0.02 Hz. The answer is C. 100 Hz. Remember that frame rate and frame are reciprocals. Therefore, if the time required to make one frame is 0.01 seconds, 100th of a second, then the frame rate is 100 Hz. What is the fundamental limitation of temporal resolution? A. Imaging depth. B. Speed of sound in the medium. C. Line density. D. Sector size. The answer is B. Speed of sound in the medium. Speed of sound in the medium is the fundamental limitation of temporal resolution. Thank you for watching. I hope this video helps with your exams. Good luck! Don't forget to share, like, comment, and subscribe.